Now another example, in this case we have to find the node voltages V1, V2 and V3, all node voltages, and also we have to find all branch currents. So current in this branch, in this branch, in this branch, in all the branches we have to find the current. So let's first find out the node voltages. We have drawn our currents, arbitrary currents we have drawn in all the 4 branches, and the voltage, now if you look carefully, this 12 volt voltage is same as V1 because this is the voltage appearing here. So that means we can directly write V1 to be 12 volt. Similarly, if you look at V3, V3 now will have negative 6 volt here, so V3 can be written as negative 6 volt. So the only voltage that we need to find now is V2. So for V2 we'll again follow the old technique that we have learned, that we write the KCL equation and convert in terms of a voltage. So here I1 is entering, I2 is entering and I3 is leaving. So I2 plus I1 plus I2 is equal to I3 is the KCL equation at node 2. What about when we convert them into voltage? Same technique. I1 is V1 minus V2. So V1 minus V2 divided by 12K. I2 is V3 minus V2. So V3 minus V2 divided by 12K, and I3 is V2 divided by 6K. So this now we have converted in terms of a voltage. Now we know what is V1. We also know what is V3. So we put that value. So for V1 we write 12 and for V3 we write negative 6. So this becomes our equation. LCM here is 12. So we multiply by 12 and then we can solve it, and by solving we find V2 to be 1.5 volt. So now we have got all the 3 voltages, so we can calculate the current. Okay, now that we have found out all the 3 voltages, how to find the currents? Well, we already had written equations for the currents. So these were the initial equations for the current. Now that we have found out these voltages, we'll put their values and calculate the current. So these are the final values of the 4 currents. But we don't know how to find we did not even draw the arrows for the currents through the batteries. Now we'll try to find these currents also. But since the batteries do not have resistances in it, so we cannot find their current through the usual way, but we'll again take help of the KCL to find out these 2 currents. So we take an arbitrary direction. We're taking from the positive of the battery, current leaving in. So this is the current leaving from the positive terminal of the battery, and in this case the current leaving from the positive terminal of the battery. So these are the 2 directions we have assumed. Now if you can see, this current, which we'll call I12, is equal to this current plus this current. So it is I12 is equal to I1 plus I4. So it is I1 plus I4, and since we know I1 and also we know I4, we can find the total current to be 2.875 milliampere. Similarly, from here I4 volt is can be found by writing KCL at this point. So current I4 is entering and I2 and I6 volt is leaving. So this is I2 leaving and I6 volt is leaving. So we can write equation I4 is equal to I2 plus I6 volt, and from here we can write I6 volt is equal to I4 minus I2. So I6 volt comes to be 2.62 milliampere.